Hello, I am Ilma. Today we will see symbols. Symbols are a type of data used in Scheme, just like numbers and strings. Numbers and strings exist in the real world, but what is a symbol? If you know other programming languages, and think that variables are called symbols in Scheme, you may have a big misunderstanding. The specific differences will be explained in the following videos, but here is a basic explanation of the concept. Let us assume that there is a package, with no description of its contents on the surface. Since there are many other packages, we need to be able to identify this package. So, let's put a package tag on the package. A modern package tag is like a sticker on a cardboard box. In the days when Lisp, the language on which Scheme is based, was written, packing tags looked different from the ones used today. A Wiretag is a piece of paper about the size of a business card, on which the name of the package is written. The edge of the paper has a hole in it, and is reinforced with round brown paper to prevent tearing. A long, thin wire runs through the hole. The end of the wire is bound to a string that is bound to the package. The tag with the name on it will lead you with its wire to your desired package. Let us consider the relationship between a tag and a package. If a clerk at a package pickup delivery station is asked by a customer for the name of a package, he will give the customer, not the package tag with the name on it, but the package to which the tag is bound. Since there is only one wire coming out of a package tag, the tag cannot be bound to more than one package. If the tag is not bound to any package, it is meaningless as a tag for tracing a package. A package tag must be bound to a single package. It is sufficient to be able to identify a single package from a single tag. Therefore, multiple tags may be bound to a single package. Furthermore, since the wire tag is only bound to the package with a wire, it can be rebound to other package whenever necessary. By binding a tag, you will be able to call the package by name. Each instance that exists in the PC memory, and can be recognized by Viivi, is collectively called a Scheme object. The numbers 30 and 3.14, and the string Hello World, are examples of Scheme objects. In general, any value, obtained as a result of evaluation, is a Scheme object. Symbols are also Scheme objects, as will be explained a little further on. Symbols in the Scheme language work just like wire tags. If wire tags are equivalent to symbols, then packages are equivalent to Scheme objects. Symbols can be associated to any kinds of Scheme object. To associate a symbol to a Scheme object is called to bind. A Scheme object bound to a symbol is called the bound value, or simply value of the symbol. When a symbol is evaluated, the bound value of the symbol is returned as the evaluation value, not the symbol itself. For example, suppose the symbol mathpi is bound to the floating point number 3.14. In this case, when the symbol mathpi is evaluated, its bound value, the floating point number 3.14, is returned as the evaluation value. This is different from the case when an S expression representing a number or a string is evaluated, and the number or string is returned as the evaluation value. A symbol cannot be bound to multiple Scheme objects. If a symbol is not bound to any scheme object, it is meaningless as a symbol for naming a scheme object. It is correct that a symbol used to name a scheme object is always bound to only one scheme object. Since it is sufficient to identify a scheme object from a symbol, multiple symbols may be bound to a single scheme object. Moreover, a symbol, bound to one scheme object, can be rebound to another scheme object at any time, if necessary. By binding symbols, scheme objects can be called by name. By the way, how are symbols identified among the input S expressions? First, the input S expression is checked to see if it is a special mark defined in scheme. If so, special processing is performed for the mark. If not, it checks whether the input S expression represents a string. If so, it processes it as a string. If not, it checks if the input S expression represents a numeric value. If so, it processes it as a numeric value. If not, it processes all S expressions as symbols. Please note that any S expression that Viivi does not know what it represents is considered a symbol. For example, any S expressions that do not represent correct numbers, such as those shown on the screen, will be recognized as correct symbols. When using symbols in your programs, it is important to avoid using symbols that are difficult to understand, and to use names that make their meanings as clear as possible. Although Viivi accepts non-English symbols, it is recommended that you use symbols that can be written in the Latin alphabet. Non-English characters should be used in comments and strings, not for symbols, to make the program easier to use. Do you remember the last time you typed in a string in the number 4 video? If you did not put the double quotes, you would get an error. Let's try typing it in. If you look closely, you will see that the error message is, the symbol is not bound to a value. This means that the symbol hello was entered, but there is no value bound to the symbol hello. Note that hello is the correct symbol, and there is nothing wrong with the symbol itself. The problem is that the symbol hello is not bound to any value. What symbols will not cause errors? Let's try typing in a variety of symbols. No luck. We can't find any bound symbols. Oh. We found it. But why is bike not allowed, and car is? And the returned value is neither a number nor a string, something we have never seen before. In fact, Viivi is pre-populated with scheme objects, necessary for running scheme programs. Each scheme object has a symbol with a unique name. The reason we did not get an error when we entered the symbol car is because it happened to be one of the prepared symbols. But you can't master the scheme language if you can only use it by hand like this, can you? So, here's the big spoiler alert. I'll show you everything. Open Table System symbol from the window menu. A window with a red background opens, different from the blue argument command window, the input port window, and the green output port window. The red background color indicates that the window is a table. The word table in the title bar also indicates that the window is a table. Viivi has several tables, all of which are used to represent Viivi's internal state. The system symbol table is a table of scheme objects and their associated symbols, that the system has prepared in advance for Viivi. These symbols are called system symbols, or predefined symbols. Looking at this table, you can see that there is a car, for which a bound value was obtained by inputting the symbol earlier. Immediately after booting Viivi, all the symbols for which bound values can be obtained, are listed in this table. Conversely, if you enter a symbol that is not in the table immediately after booting Viivi, you will see the symbol not bound error that you saw at the beginning. What do you think? Did you think the number of scheme objects prepared by the system was too many? Or did you think it was too few? The number of scheme objects that should be provided by the system in advance as defined in R5RS, is far fewer than the number of built-in objects in other programming languages. Therefore, the scheme language is easier to learn than other programming languages. And you don't necessarily need to know all of them. You only need to learn the scheme objects listed here that you need to use. The letters in the predefined symbol column of the system symbol table are shown in white text. This means that these symbols are used as input S expressions. On the other hand, the value column is displayed in green text. This indicates that these values are scheme objects. The letters in the other columns are displayed in wheat color. In Viivi, all descriptive characters that are neither for S expressions nor for scheme objects are shown in wheat color. The same color conventions are always followed when displaying text on input-output port windows, as well as tables. Any of the symbols listed in this table should yield a bound value. Choose any symbol you like and enter it. There is an uppercase math-pi symbol. This is bound to a floating point number, representing pi. Let's choose simple symbols and type them in. Begin. Display. Read. Zero? Oops, it needed a question mark after zero. Symbols are the same as the other S expressions, in that an error will occur if even one character is wrong. Have you noticed that, when a symbol is being evaluated, the corresponding row in the system symbol table lights up orange? This is called an orange cursor. The orange cursor lights up in the same way for the input-output port window displays. By paying attention to the orange cursor on each window, you can follow only the relevant items at each step of the evaluation process, without having to search through a large display area. Take a close look at the bound values in the system symbol table. Almost all of the bound values contain a sequence of the word procedure. The math-pi line, which is a floating point number, is an exception. Like numbers and strings, procedures are of course a type of scheme object. Although there are detailed groupings in the category column, in this tutorial, we will refer to all of them as procedures, without distinguishing them in detail. And welcome to the Woods of Scheme. The procedures listed in this table are the very inhabitants of the Woods of Scheme. In an averaged game world, the inhabitants of the woods appear little by little. In the woods of Scheme, however, all the inhabitants greet you at once. Each of them has her or his own job, and they are all your friends. When you want them to do some work in your program, you can call them. Of course, when you call them, you use the name of each inhabitant, that is, the symbol bound to the procedure. They should appear before you immediately, and perform the task assigned to them. However, I have not yet told you how to use the specific spells. Look at the top of the table. In the predefined symbols, you will see the plus and minus symbols. The procedures plus and minus, to which these symbols are bound, can be used to add and subtract, respectively. Thus, in the next video, we will try to do 4 arithmetic operations in Scheme, in order to learn how to call procedures. Please look forward to it. Thank you for watching this video. See you next time. To continue learning, please subscribe to the channel by clicking the subscribe button. Thank you.